Hi there. In this video, we're going to talk about confidence intervals, and we're going to use a method called bootstrapping. So this is the moment you've been waiting for, right? We don't know our population, and we don't know our population parameter. So how do we estimate, how do we form our confidence interval? Because up until now, we've been pretending to know what the population looked like so that we could understand sample-to-sample variation. And now we're taking that away, okay? Now I also want to talk about one other thing at the beginning here, and that's theoretical versus simulation methods. So if you've taken statistics before, you've likely used theoretical methods. Not necessarily, but I think that was it has been a more common way to do it. So I want to just talk about the difference there first, and also why you should do the simulation method as well. So the theoretical method or theoretical calculations are based on a model, right? So we have to have a mathematical model, such as we've seen the normal model or the t-distribution, but we haven't seen the t-distribution yet, but such as what we've seen, the normal model. We haven't formally done the theoretical normal model yet, but we will later in the course. So these methods were developed around the 1930s, and so computers were not don't think they were invented yet. They were maybe invented, but they weren't in fully, realized form. So even though this idea of simulation was there and could be done with objects, the things we can do now are much, much different, much more powerful. Computing power has increased. So simulation methods are now becoming a lot more commonly used. And as you've seen, all the free applets we've been using online, those allow us to do a lot of simulations really quickly. Okay, so that's why we're focusing on simulation in this class. But we will also do some of the theory, okay? Now, simulation methods, you've seen some of this already. Use a computer to run many trials quickly. Of course, you can flip coins or use dice or anything like that, but if you want to do a lot of trials, 1,000, 2,000, it's probably best to use a computer to do that. The beauty of simulation is you don't have to know the theoretical model or have a theoretical model. As long as you're simulating the real-world process, with a deck of cards or coins or spinners or anything like that, then you can get results, okay? So there's a little more flexibility with the simulation, but the theory can be nice as well. So right now we're still focusing on simulation, and we will come back to the theory. So that's why if you have had some statistics before, you might notice we're doing things differently. So it is important to do the simulation methods because that's going to be more and more popular. Okay, so now let's get to bootstrapping, okay? So bootstrapping is a method developed around 1979 by Bradley Efron. And so, again, now that computing power has increased, these simulations are being used more frequently. You may have heard the saying, picking yourself up by your bootstraps, meaning just picking yourself up with nothing but yourself, getting your results with nothing but yourself. Now, there's some issues with that saying and sort of meritocracy and privilege, but I'm not going to go into all that right now. But they, for some reason, chose to use that name, and I think it'll become kind of clear when I show you what this is. There's a lot of text on here just because I don't want you to have to write it all. So bootstrap samples. Okay, so in real life, we just take one sample from our population, right? That's all we want to do is one sample. Now, if we had more resources to do another sample, like repeated sampling like we had done with our simulations, if we had more resources to do another sample, it would be better to just take a larger sample. Okay, so we don't want to be repeating thousands of samples or anything like that. We're just going to have one sample, okay? Now, we don't have the information from our full population, okay? So it is really important to get a representative sample. Now, if our sample is representative, we could think of our population as many copies of this sample. So I have an image here for you. Here's a little sample. It's a small sample because need to fit this on a page. So normally we wouldn't sample 8 people, but in this case, our original sample has 8 people in it. And you could think of, as long as this is a representative sample, so that's a big if, right? Think of this, I've just copied this image many times, about 12 times, 6 times. So think of just this population as many copies of this sample, okay? So if you're with me, stay with me. Then what we do is we are going to take many samples from this population, okay? Because we don't know, we don't have the full information for the real actual population. So now this is our pretend population. So I put it in quotes. And we're going to keep taking samples of 8, but we can't just do the original 8 all the time. It would be the exact same sample. So what we do, let me move this paper out of the way here. It's called, another way to talk about this is it's called sampling with replacement. So you could also think of it as our original sample, this original 8 people, but we're going to select someone one at a time. So here's our sample. We select 1 through 8 using names or numbers, some kind of identifier, and then we put that back in. And then we sample again, and we put it back in, sample again. So that's called with replacement. Okay, so I've got 3 different samples. I did that with a random number generator, and I used numbers 1 through 8 because I don't know these people. They're made up. But you'll notice the first person came up twice, and our 4th person came up 4 times. Our 7th person once, and our 5th person once. So this is only using our original sample, but we've resampled, and it's called resampling with replacement. Now I did that again. Oops, something happened to my middle arrow here. Did that again, and you can see we got a different combination, and people can be repeated because that's with replacement. They're going back into their name goes back in the hat, and then they can be pulled out again. And then again, another same idea, but different sample for Bootstrap sample 3. So these are called Bootstrap samples, okay? What we're going to do is make a distribution out of this. So just like we did with a sampling distribution. So think sampling distribution is from the population. Okay, we are going to do repeated samples, and we're going to have specific applets to do this, and I'll show you all that. It's been shown that the sample-to-sample variation of the Bootstrap distribution is very close to that of the sampling distribution. Okay, so the Bootstrap distribution is from one sample. Versus the sampling distribution is from the population. Okay, now how can this work? Are you skeptical? Because I was when I first heard about this. I was like, wait a minute, how in the world can this be accurate? Because we're only taking one sample. Okay, so it does need to be a representative sample. I would not use a convenience sample or a voluntary sample for this. But it has been shown, and it's been shown by simulation. That's a great way to show it, right? How do you test this? Is you compare. You take samples from the population, then you take one sample from the population, and you do your samples there, your Bootstrap distribution, and you compare the two. So I will do a little bit of this, but I don't have quite the ability as some other people who've got more, better coding skills than I do. So I'm going to do an experiment at the end. So first I'm going to show you how to use bootstrapping. If it's really bugging you, you can skip to the last video and then come back. So there's an optional video where a guy, I think from New Zealand, shows a lot of simulations, and he shows the Bootstrap distributions looking very similar to the sampling distributions. So feel free to watch that if you want to before the next one, if it's bugging you. And I will do a little simulation of that at the after I show you how to do it. Okay. So I'll see you next video where we'll actually take a Bootstrap sample.